screen.
Yep. So just one other thing. We do have like moderators and like helpers in the chat. So if you have any questions, feel free to type them in the chat, and then the moderators and the team helpers will relay them to us, and we'll try to answer them as best as possible given the time constraints. All right. Begin.
So hi everyone. I hope you're all having a wonderful week. Today I'm here with my friend Omar from McMaster's GDSC, Google Developer Student Clubs, and we're going to do a very quick and brief intro on how to use OpenCV with Python. And hopefully by the end of the session, you'll be able to do a few quick tricks with OpenCV using Python and the PyCharm IDE. So what is computer vision and how it's affecting our current society in 2022? So computer vision is basically the ability for the computers to be able to use cameras and kind of process the images and gain valuable information from those images. And nowadays we can see this being used for AI object detection, recognition, computational photography, autonomous vehicles, and security and encryption. However, today we will be focusing on a particular use case of this new technology, which would be mainly facial recognition. And yeah, so let's see. We came across this idea of sort of processing images, but we need to have a tool to basically have the ability to do that. And OpenCV is one of the leading computer vision libraries developed in 2000 by the Intel research team. And it basically provides the basic computer vision infrastructure. This library is available for all major programming languages: Python, JavaScript, C, C++, and that's one of the reasons it's so versatile. Because if you're more comfortable with using Python, you can do that if you feel free to. And it's also currently maintained by big research firms, so it has a lot of support behind its back. And yeah, that's why we think it's a great tool to learn. So for this project, basically workshop, we will be using the PyCharm IDE as well as Python. You can use any version, I guess, you want. Hopefully you guys have the newest version though, just to reduce the number of errors that we might run into. So I will. We do assume that you guys have already installed Python. If not, it's you can install from python.org, and also the community version of PyCharm. And this could also be installed by I think you can just Google download PyCharm, and you can go to its download webpage and download from there. And so first we're going to start by just opening PyCharm, and I have PyCharm right here. Usually takes a few seconds to load. So the screen that you guys might see might be a little bit different from what I have right here, but essentially what you guys have to do is go to Files up here and New Project right here. And so here we need to make sure that we do have the Conda interpreter selected. I think by default it's actually virtual environment. However, we need to make sure that it's Conda. We did run into a few issues running with virtual environment, so we just want everything to go as smoothly as possible. And once you select that, I'm gonna go create. You guys won't see this. It's gonna do a new window, and it will start creating our environment. This might take a few seconds or so. Yeah, so we're up, and now what we're going to do is we need to make sure that we have OpenCV installed. So what we're going to do is we're going to go to Files, we're going to go to Settings right here, and it's going to open this menu, and we're going to go to our project, Python project over here, and Python interpreter, and we're going to select this addition sign to install the package, and we are going to search. I think it's connecting to the servers. we are going to search OpenCV and we are going to select this and install package. And it should hopefully be completed relatively quickly.
All right, that should take a few minutes. So I guess I'll take over.
Sure.
Depends on the computer.
Oh,
Works
yeah,
fast
it
for
just
parser.
installed
Although
successfully.
yesterday it took me a few minutes for it to install. So while that's installing, what we'll
It's
do is
installed, Omar. So
yeah,
yeah. Should I go through the version as well, or?
not at the moment.
Oh,
It might be
sure,
installing for other people.
sure.
All right, so
Gonna stop sharing screen.
yep. So what I'll do is John. So as we mentioned in this workshop, you have to go to your settings menu for PyCharm when you have your project open, and then add that library to your interpreter. The library is called OpenCV, yes. All right, so I'll go ahead and share my screen. So we'll continue talking about OpenCV while your library installs, or if it's not installing, please let somebody know in the chat and they can try to help you out with that. All right, so based on basic OpenCV concepts, and these concepts apply to computer vision in general. So usually what we have is called a vision pipeline. So the way vision pipeline works is that you have input data coming from a source. It could be a camera, it could be a video file, it could be a YouTube video, for example. Anything that has image data in it, you can use as input data to your vision pipeline. And then what you do with it is pre-process it. So if you have your phone camera, for example, your phone camera actually runs quite a few algorithms before it shows you that picture, even before you do anything with it. You could like change the size of the image. You could change the shape of the image, things like that. You could change color spaces, which is something we'll go through in this workshop. And then you can select areas of interest. I don't know if you ever like put your phone up with the camera on it, might start detecting things like faces and things like that. You could do that. And then what you can do is you can extract data about the things that you detect, like features. It's called feature extraction. And then you can use that for object recognition. So, hey, there's a face over there. You could do feature matching, things like that. And then we're not going to go through that last part, the action part, because we're just going to show you how to create the first four parts, the first five parts. Action would be something like if your Tesla vehicle has cameras mounted on it and they have their extremely complex vision pipeline for self-driving, it will take all of this information and try to come up with driving commands. Like it will tell the car, like, steer left, steer right, brake a little bit, or speed up. Things that it would do. That would be an action, for example. Let's take a look at the chat. Yep. All right. Thank you everyone for helping out. And again, if it's not working out for you, I would still recommend sticking around just so you can see the concepts behind the code, and then you can work out later. This workshop is recorded. All right. So for our first coding example, what we'll do is we'll try to get input from a video source, a video file, and a few things for the code that we're going through. Because we're doing live coding, and usually what happens is that some people have weird syntax issues, or there's like a variable name that's wrong. So what we did was we compiled our code into a GitHub repository that we'll post in the chat right now. And we also have a Google Drive folder with assets that you need. So we are going to use video files and images that are specific to this workshop. There's a Google Drive link. Thank you, Young. There's a GitHub link. I would recommend opening that on your phone or something like that so you can reference it as you go along. Or if you have a second monitor, that's awesome. And I would want everybody to download files from the Google Drive. Just download it as a zip, and then we'll see what to do with that. All right. So once I open the Google Drive link here. I should be able to download all of these files, right? You just select all of them, and then you can just click download, and it should zip them up and let you download it, right? So I already have them. It will download them for me. You can use any IDE you want as long as you have a Python interpreter with OpenCV installed. The reason to use PyCharm is because it's much easier to install OpenCV in it rather than using command line. Yep, so you can download it. I already have it downloaded. And then what you want to do is inside PyCharm, if your project has already been set up, what you want to do is in the left file tree here, that's what they call it, a project explorer. You can right click your Python project directory and then go to open in. And if this might be different if you're on Mac versus Windows. On Mac, you'll see open in Finder. On Windows, you'll see open in Explorer. And then what that should do is it should take you to the directory where your project is. And then once you're in here, what you can do is you can drag and drop all of those files into this directory. I already have it in a different directory, so I will just copy them from here. What you want to do is you want to paste all of these files into this directory. And then if you've done that, in PyCharm at least, if you're using a different ID, it could be different. They should show up on the left here. This means that these files are included in your project. So yeah, any questions, concerns about that? Like if you have any issues with that, please let us know in the chat. We'll try to take care of it as best as possible. And as I said before, Jan, could you post a GitHub link once again? Yep, thank you. So I would recommend opening up that GitHub and have it maybe on your phone, or if you have a second monitor, you can have it there, or a tablet, just so you have the code to reference. And I will reference that GitHub very often because there is boilerplate code that is very annoying to write and doesn't really have any conceptual value to using OpenCV that we will just copy paste from there into your code files over here. I see somebody's already checked the video files. That was supposed to be a surprise. All right, so let's start with coding because that's what we do here. So when you create a PyCharm project, it should have already created a file for you. What I've just gone ahead and renamed it to ex_1. That's example 1. All you do to do that, Michael, there is a Google Drive link. Maybe Jan can post it again. That's where the video, like the asset files are for this project. Thank you. So you just go ahead and rename it. It will probably be main.py for you. You can just rename it to ex_1 or any other. The name doesn't really matter. All right. So the first thing, if OpenCV has installed properly, hopefully, it has quite a few issues when you do that. What you want to do is you want to import CV2. And CV stands for computer vision. And there used to be a previous version of OpenCV, which was just CV. The newer version is called CV2 as it's like a syntactic thing. You'd think it would be called OpenCV, but it's just called CV. So it is what it is, right? So OpenCV has many different functions, as you'll see in a bit. It has different functions to do basically everything you can think of in terms of like basic computer vision infrastructure. So as our first example, we want to be able to read a video file in the OpenCV. So how do we do that? We'll create a variable called cap, and we'll set it to cv2.video capture. So if your OpenCV installed properly, there's another hint. If you do cv2 dot, it should start showing you a lot of autocomplete things that it thinks you want. What we'll do is we'll use this class called video capture. And again, we'll use like programming terminology here. Everyone might not know what a class is, and that's perfectly fine. You'll learn it eventually in your courses. Just don't worry too much about everything that is not known yet. So we do cv2.video capture, and that lets us capture video from various different sources. You can even use it to capture your webcam, for example. You can use it to take a video input from a file, or you could give it a video link from the internet and it will work, right? So over here on the left, if you have PyCharm open or any other IDE, you will see vid1.mp4. So that is the video we are using for this example. So we'll just tell it to load vid1.mp4, and that just loads it. And OpenCV also provides great functionality for debugging purposes, for like testing your stuff and seeing the outputs. It lets you create a window, and you can put any image inside that window. And the way you create that window is by using this function cv2.named window. And then what you do is you give it a video window name. Like, what do you want to call that window? Every time you open a program, it has a name. We'll call this video file. And we'll give it a parameter called cv2.window normal. I wouldn't worry too much about what that means. All right. All it does is it lets you change the size of the window, because if you don't do that, your window ends up taking up your entire screen, and that's annoying because you want to be able to see other things too. All right, so now that we have this code, if you just run this, so the way you run a file in PyCharm is, for the first time when you run it, you just right-click that tab on the top, and then you just go down here and run ex_1. And if it works, you will just see a window pop up and close immediately because the program exits and the window closes, right? All right, so now for the part where we actually read the video. So the way we do that is by using two variables. So RET, that's the most commonly used variable, and IMG for image. And then we'll do cap.read. And what this does is it will read the first frame in your video, right? Whatever it gets from the video, the first frame. And what we can do is, so you might be wondering why there's two variables here, and you can do that in Python. That's pretty much a Python only thing where you can do this. RET is like a short form for return, and it basically tells you if reading from the video is successful or not. So there could be scenarios where, let's say you're streaming from the internet, a video, and you call cap.read, and cap.read is like, hey, I don't have internet connection. It will just return false. And if you try to use this image, it will throw errors in your program. It's much better to know that your image didn't really get anything rather than just finding out by your program crashing. So that's why they have the return variable there. And then what we can do is we can actually display this image inside our window. So the way we do that is we use the cv2.imshow function. And then all you do is you tell it which window you want to display your image on. And it is case sensitive, so you want to make sure that this name and your window name matches. And then all you do is you pass in the image as well. So window, name, and image. Once you do that, there is another thing you have to do. As you remember, if you just ran the code earlier, the window just opens and closes. So you have to tell OpenCV to wait till we tell it to do something. And then the way you do that is by using cv2.waitKey. And then if you notice, if you're on PyCharm or any other IDE, there is a delay parameter there that is highlighting. Default is none. So if you put 0 there, it will wait for us to press a key on our keyboard. That's where the wait key comes from. If you set it to 0 and you just run the program, right? So cv2.waitKey 0, you run that, and you should get this window with this picture. That is the first frame of the video that we loaded. And if you press space or any other key on your computer, it will just go away because we have nothing afterwards. So let's get rid of that for now because we want to be able to loop over the entire video. All right. So the way we'll do that is we'll use a while loop. And if you don't know what that is, don't worry about it. You'll learn it eventually. Just follow along. If you do know, that's great. We'll use while return. So while return, as I mentioned before, represents the fact that you were able to read something from your image for your image source, your video, or whatever you're using. You can call CV. We'll just remove this as well because we don't want to show the image over here because we're not checking if the return was true or not. So we'll just replace that over here. The video file, we want to show image in video file, that window. And then we want it to wait till we press a key. All right. And then what we can do is inside this while loop, because it is a while loop, we can go ahead and read again. All right. So once we do that, it will basically, it gives us a mechanism to loop through the entire video. So if we run this code, what you'll be able to see is that a window opens, but when you press a button on your keyboard, I'm pressing the spacebar at the moment, it doesn't close, it will go to the next frame. And if you hold that button, it will just keep going. And once your video is finished, this is a 3-second video, it's not that long, it will close the program, your program will exit. All right, so were people able to get to this checkpoint? Any questions? I went to it pretty fast, didn't really. Can I zoom in? Probably. Let's see. I am not appearance maybe, or maybe it's in settings. That's probably where you'd find it. Editor, maybe you can increase the font size. There it is. Let's see. Maybe we can make this 15, 16. Is that better, Alan? Oh, I don't know if that works on PyCharm on your. I think that's a VS Code thing. All right, so people were able to get to this checkpoint. That's great. And if you weren't able to get here, that's fine too. Let us know in the chat if you have any issues. And so that was a very basic example of reading something from a file and displaying it in a window inside OpenCV. Another thing that we would want to mention about this wait key function is you can pass in a non-zero number that is greater than 0. So if you pass in 10, this will wait for 10 milliseconds for you to do something. And if not, it will just go ahead to the next. It will just go ahead. So if you run this code, if you instead of 0, you pass 10, the video will run on its own and it will loop through it because it only waits for 10 milliseconds for you to do something. And if you don't, it'll just go on its own. So just leave it at 0 because we like to be able to control the frame that we're reviewing. And that's great. So that was our first example. So if you go back to the presentation real quick, we do have examples 2 to 4, and then finally the phase tracker algorithm that we promised. All right, so for example 2, what we'll do is we'll walk through some algorithms here that OpenCV provides that are pretty cool. So first of all, we'll start off by a blur algorithm. So we'll create a new Python file for this, and we'll call this. So the way you do that is by right-clicking your project folder, new, and Python file. And we'll call this one ex_2 to be consistent with the GitHub repository. And Young, if you could post that GitHub link again, that would be great. If you look at that GitHub, we do have a file called ex_2.py. So that is the one I'll be referencing when coding here. So you can have that open on the side if you want to take a look. And again, I want to emphasize this as much as possible. Whenever we use OpenCV, we want to import CV2. That's like the first thing we should do always. All right. And as I mentioned before, we will be using video capture optics to read videos, and we'll be using the same video as before. All we'll do is we'll blur it. So as we did in the previous example, we'll create a variable called cap. You can call it anything. And we'll do cv2.video capture, and we'll give it the file name vid1.mp4. All right, should be pretty good by now. And for this one, what we'll do is we'll create two windows instead of one, because what we want to do is we want to show the original image and the blurred image side by side. So it's much easier to see what's going on. And to do that, we'll use the cv2.named window function once again, and we'll use it twice because we want to create two windows. So we'll call this one video file. And again, we want to pass in that parameter cv2.window normal. Again, you can look that up in documentation what that does. It's not that important to understand. And we'll create another window called cv2.name. We'll use cv2.name window again, and we'll call this one blurred. And again, you want to give it that parameter cv2.window normal. All right. So again, if you want to run a file inside PyCharm, you can just run. My headphones decided to turn off there. I apologize. So what you want to do to run a file and open in PyCharm is right-click the tab, and then you can just go to the run in the menu there. And this should just create two windows and it will close instantaneously because we don't do anything with them and the program exits. So as we had before, you want to read the first frame from the video. So cap.read, return image. And then while reading from the video file is successful, so while return is equal to true, we want to blur our image that we're getting from the video file. And CV2 has a lot of functionality built into it. Like if you just do CV2 dot, you'll see there is a lot of stuff. And if you just keep scrolling down that list, you could probably keep going for a very long time. So if you probably guessed, it has blurring functions built in. And the algorithm we're going to use here today is called Gaussian blur. There are different types of blurring algorithms that produce different results. You can look them up later. So to use that blurring algorithm, we'll use cv2 dot Gaussian blur. This is where having the GitHub open is great because the spelling might not be the easiest to understand. So cv2 dot Gaussian blur, and we pass in our image that we want to blur. And then what we do is so the way this algorithm works is that it will start off in the top left corner of the image, or it could start off in any corner of the image depending on the implementation. And then it will take a small square of that image and blur it. And then it will move to the right. It will blur it. And it will move to the right again. It will blur it to the right. And then it will move down. It will blur it. And then it will blur it again. And then hopefully it will go through your entire video, just scanning it and blurring it. And what you can do is you can define the size of that box that it blurs at once. So the size of that box will actually define how blurred your image is because you can control the sensitivity of the blurring algorithm. And to start off, we'll pass in a square of 9 by 9. And the way you do that, this is a tuple in Python, if you know what that is. You just pass in square, like brackets, 9 by 9. The brackets are important there. And sigma x, that's a mathematical thing. If you want to understand how this algorithm works, feel free to look it up. It will make more sense. We just pass in 0 for that at the moment. And then what we want to do, as we mentioned before, we want to actually show these two images side by side. So while we are at this point, are there any questions? You can unmute if you want, type them in the chat. Ready to answer if you have any questions. Good. All right. So we'll use cv2.imshow once again. And in the blurred window, we will display. So another important thing that I didn't do here is you actually have to save this into a different image. So when you blur an image, it doesn't do it on the original image. It makes a copy of that, blurs it, and then gives you a separate image. So you have to assign it to a variable. So we'll assign it to this image called blurred. So we just show blurred inside the blurred window. And then we'll also show the original image inside the video file window. We'll just pass an image. And then what we want to do is we want to do cv2.waitKey so it doesn't just closes on its own. Then we'll pass in 0, so it will wait for us to press something on our keyboard. And then we can just copy this code over here again. So it will just read the next frame afterwards. So any questions up to this point before we run the code? All right, awesome. So if you go ahead and run this code, right click the file, run ex_2. What you should get is two windows. They might be on top of each other like this. So you just separate them. And because it might not be that obvious, but the image on the left is why do we pass return image equals cap read 2 times? So that's right. The first time we do it is to read the first frame of the file, the video file, and then to continuously read it, we want to read from it again, right? So cap.read will return a video frame. So if you read it once, it will only return one image. Krish, I will open up the windows again. I'm just explaining something here. Yeah, so cap.read will read only one frame. So to continuously read it, you want to call this function many times inside a while loop or a for loop. So that's why we have it there. That answer your question? Oh, great. I'm not sure why the light in this room is based on motion. So I will have to get up intermittently for it to turn on again. Because I don't want to do this in dark room. You won't be able to see me. All right, so let's bring those windows back. They should be here, right? So if you notice the image on the left, much sharper, much more clear than the image on the right, because we blurred it, right? And as I mentioned before, it goes around, it looks at like a specific section of the image, blurs it, next section blurs it, keeps going, scans the entire image, blurs it. And the size of that box is defined by this over here. It's a 9x9 box. So it will blur 81 pixels at a time. It's a 9x9 square. And you can stop the code by using this red square in the top right. What we can do is we can go ahead and play around with these values over here. So it has to be a power of 3, I believe. So this is 3 squared. So 3 cubed is 27 by 27. And once we run that again, you'll notice that it is much more obvious that the image is blurred. It's blurred a lot more than it was before, right? Like you can clearly tell that's blurry, right? And if you press any key on your keyboard, it will progress to the next frame. And if you hold it, it will just keep going till the video's over. And if you really want, you can even go even higher. I believe the next one is 81 by 81. If you run that, I'm not sure if that'll work. Now that is really blurry. You can't really do anything with that. All right, so that was our second example of blurring things. That was one of the algorithms that OpenCV provides, and it's a very commonly used algorithm. So any questions about that? Yeah, it's cool. Is there any way to unblur an image? Actually, I'll answer Krish's question first. Why does it need to be a power of 3? Isn't the kernel just based on having any odd number greater than 1? So there's a central for each pixel's blur. Actually, that might be more accurate, Krish. Every time I've tried it, it's always been a power of 3 that worked. If I use something else, it crashes, but that might be true. I'll have to double check that. Why does it have to be a multiple of 9? So it doesn't have to be a multiple of 9. Whenever I've tried it, a power of 3 has worked, and 9 is just 3 squared. So Aaron, to answer your question, is there a way to unblur an image? Actually, Krish, let's try that. 15, 15. Yeah, that works. So I think your explanation makes a lot more sense. It's not just powers of 3. So 15, 15, 35, 35, that would work too. Yeah, so it has to be an odd number, as Krish mentioned, because you want to be able to have a center for your blurring. Because if you have an even number, there's no really way to. So if you have a center and you have just even numbers, you won't be able to really pick something and then divide like evenly on either side. So you want to have an odd number. That makes a lot more sense. Thank you, Krish. Yeah, blurring can get rid of noise from an image if you want. Probably. I haven't really looked into directional Gaussian blur, but I'm sure that's a thing. 1535, let's try that. I haven't tried these numbers myself before. Yeah, that works too. So I believe, as Krish mentioned, this should blur in a specific like direction, I guess. Or maybe not for this one. That would be a separate algorithm. All right, so if there's any more questions, we can answer them after the event. So Aaron, to answer your question, is there a way to unblur an image? Not really. I don't think that would make sense. I don't think that's possible because I believe there are many different ways to get to a blurred image. That's the same. Does this change the size of the video? No, it shouldn't change the size of the video because you still have the same amount of pixel data in it, same amount of images. They shouldn't really change the video size. It's not really compressing anything. Although maybe there is something that could do that using blurring. I'm not sure. So the next thing we're going to discuss is example 3. So it's going to be color space filters. The last argument there is, I believe it's sigma x. I'm not too sure what it describes. It's probably something to do with the matrix operations that are happening in the background or like the algorithm itself. Usually you pass in 0. Oh, there you go, Aryan. All right, so we'll go ahead to the next example because we're cutting close on time. So color space filters. So before we start that example, I just wanted to go through this slide over here. So there are different color spaces that represent all different possibilities of different colors. So RGB is the most commonly used color space. It stands for red, green, blue. You probably, if you're a gamer, you have RGB strips all around your home, right? Because it gives you more FPS or something like that. But you can use that to represent, I don't remember the exact number, but it's like in the millions of colors. So RGB is like the most commonly used way to represent colors inside a computer, but there are different ways to represent it. And one of them that we're going to use today is called HSV. So it stands for hue saturation value. And I believe it was created because it represents how humans see colors rather than like, because humans don't like have like parameters in their brains for like all different possibilities of colors. They kind of look at a color and then they see how bright it is, the shade, and then you'll see how you compare the brightness and darkness. You might say something is light blue, you might say something is like dark green, right? You select the base color and then you try to get a shade of that. That's kind of what HSV is trying to do here. So you have a color wheel that you can choose from. Like it represents the base colors, and once you move inside, it's brighter. You move downwards, it's darker. So that's how that's represented. And there is another one called HSL, similar idea. You move upwards, it's brighter. You move downwards, it's darker. And then you can select around the color wheel. That one is hue saturation lightness. It's also called hue saturation luminant. We're not going to look at that one today. We're going to look at HSV to implement something like a color filter, for example. All right, so let's get back to coding. Let's go back to our IDE. And what we'll do is we'll create a new Python file and we'll call this ex_3. So example 3. And this file is also on the GitHub repo. Young, if you could post that again, that would be awesome. All right, so for this example specifically, there is quite a bit of boilerplate code to create like the GUIs and things like that. So what we'll do is we'll write some of it, but we'll also copy paste from the GitHub. And I will also probably paste the code in the chat because everybody might not. Actually, everybody should have access to it on their computers. So again, whenever we start working with OpenCV, you want to import CV2 as always. And for this one, we'll also import NumPy as NP. Don't worry too much about NumPy. It's a very famous mathematical library for like numbers and array operations for Python. And for this one, we'll actually use an image instead of a video file. So to load an image inside OpenCV, what we'll do is we'll use the cv2.im read function. All right. And we'll use shapes.png. If it's on Google Drive, Young, if you could post that again, that would be great too. It's in the Google Drive. You can download from there, drop it into your Python project directory over here. All right. Thank you. So what we'll do for this one is we'll create two windows because we want to show two things in this example. First one's going to be called color space. Typo there, sorry. And then again, we want to pass in cv2.window normal. And we'll create a second window called cv2.name window, and we'll call it filter. And again, cv2.window normal. All right, so now we have read an image. We have two windows. And then what we'll do is the next part of the code is very boilerplate. It's just literally creating track bars inside a window, and you can look up how to do that. So because it is a lot of lines of code, we'll just copy it from the GitHub. So if you go to the GitHub and go to ex_3.py, what we'll do is we'll copy from lines 17, actually not from line 17, from line number 9 all the way to line number 52 into our code over here. This is from the GitHub. Again, you can open the GitHub link, it's in the Zoom chat, and go to ex_3.py and copy paste this code from there. All this does is really just create track bars. As you can see, it's a lot of work just to create, like, actually we do have 6 track bars here, so don't worry too much about how it's created. It's not that important to understanding computer vision. And what we'll do is we'll create a function here. If you haven't done that before, that's fine too. Just try to follow along best as you can. So we'll call this function create mask. So define create mask. And what we'll do is, let's say you want to convert from an RGB image to an HSV image. Because they all represent the same colors, you can convert between them quite easily. And of course, OpenCV has a function for that too. So what we'll do is we'll create a variable, we'll declare a variable called HSV, and we'll assign it to cv2.cvtcolor. So that is a function that converts between color spaces. You give it the image that you want to convert. So for us, it is cap. We declared it up here, and that is the image. All right. And then what you want to do is you want to give it a parameter that describes which color space you're in and which color space you're going to. So the way you do that is by using cv2.color. And this one will use RGB to HSV. So if I just get rid of that for a second, you'll see that there are a lot of color spaces, right? There's a lot of stuff here. Not all of them might not be color space conversions, but most of them are. Right, there's a lot of stuff that you can do with this function. So again, for us, it was RGB to HSV. That's the conversion that we're trying to do. That will tell OpenCV what to do. And because we're trying to create something like a filter, you have to define what you want to filter in or filter out. So you have to define a range of things that will be filtered in or filtered out. So the way we'll do that is by using a list or a NumPy array called lower bound. And don't worry about what a NumPy array is. You'll learn it eventually. So all we do is, I'll do that again. So assign it to np.array. And then we pass in a list of values. So we want to pass in our hue, sat, and val. So that represents hue saturation value, as we had back over here, right? And we want to define an upper bound for the things that will filter in or filter out. So this one is just the variable names for the lower bound, but we have upper versions of them that are assigned using track bars. And you'll see it will make more sense once you run the code. All right. And what we'll do is we'll create something called a mask. So mask is equal to cv2 dot in range, and you pass in the image that you want to filter on, and then you can use your lower bound and your upper bound. And what this will do is it will create a mask, and that might not make much sense, but we'll show you what it means. And we'll just display this in the color space window. Remember that it is case sensitive, so be careful about what you put in here. It should match exactly what you have up here on this line. All right. So once we have that, we can just pass in our mask, and it will show you what the mask looks like. And then on our side of the function, we can just do a while loop, and we'll say while true, create mask. We'll call that function. And then we'll do cv2.wait key 10. So we'll wait 10 milliseconds for us to do something. And if it doesn't, it will create another mask and show it in the window. It will just keep doing this, wait 10 milliseconds, do that again. So while loop. All right. And let's run that. So again, to run the file, right click the tab, run ex_3. Once you run that, you'll see that the filter window has nothing in it. We created it, but we're showing nothing in it. So it's just black. And the mask window, this is where we're showing our mask. You'll see we have 6 sliders down here that define the upper and lower range of what we're filtering or filtering out. So these are like RGB values. If you've done Photoshop or things like that, you might know what that is. So let's just move hue upper to the maximum. Let's move saturation upper to its maximum. And let's move value upper to its maximum. So now the image just turned completely white. So all this is, it represents a mask that you can apply to the original image. And if the image here, this mask image has a white pixel somewhere, and you multiply that, and if you multiply that with the pixel in the original image at the exact same spot on the image, you will get the same color, you will get the same value back. But if it is black, you'll see, like if you start moving the saturation slider down, if it is black, it won't be in the image. So if you multiply something by 0, so the black thing there, the black pixel is 0, you will just get nothing. You'll get nothing there. You'll get 0, right? So how do we multiply our images per se? We'll close our program and we'll edit it. All right, so we're showing our mask. What we want to do is we want to create something. We'll create an image called image filter, and we'll assign this to cv2.bitwise and if you know what bitwise operators are, that's great. Don't worry too much about the parameters. We'll just pass in mask. So this is a name parameter. So image filter is equal to cv2.bitwise and pass in cap. I don't exactly remember why we do it twice. Maybe someone in the chat knows. They can post it there. And you pass in the mask. All right. And what this does, it will basically go through each pixel on the exact same image, and it will multiply. It will actually do an AND operator, but in reality, it's mostly a multiplication. So if you have red over here and you have 0 over here, like black, you'll get black on the original image. If you have white and you have like blue in the next pixel, you'll get blue back. And we'll see what this looks like. So cv2.imshow, we want to show this filtered image as well. So we named our window filter up here. We'll use the same name. Remember, it's case sensitive. And we'll pass an image filter. So any questions up to this point? Feel free to ask in the chat, or maybe unmute yourself too. That's fine as well. All right, awesome. So we'll go ahead and run this again. So once you run that, you'll get two windows, and filter actually has something in it. So as I said earlier, if your mask has a 0 value, oh, if you try to move the sliders, it closes the window and says Python quit unexpectedly. In that case, what I recommend is just literally copying the code from the GitHub and pasting it into your file, because it's pretty hard to debug like issues on over the chat. And then yeah, usually it's small things that happen. You can just copy paste it from the GitHub. That's why we have it there, right? That's perfectly fine. So as I mentioned earlier, if your image is black over here, it will be black in the original image, all right? And then once again, we'll put all of our upper sliders to the max, all right? And the image will just turn completely white as it did before. And that means every pixel of the original image is being passed through the filter. So it will pass through the filter. And as you can see, that is the original image. If you go back and just open that file, shapes.png, that is the original image, right? Just different colors for fun. And if you bring those back up, all right, you can mess around with the slider values. Like you see, as it went black over here, it went black in the original image too. You can bring that down even further, right? The further you bring it down, all of them go away, right? You can play around with that value. You can play around with this value. This one's more sensitive. This one's, yeah, also very sensitive. All right. You can play around with the sliders and you can filter out what you want in an image. So example for this is, I have a green door in front of me right now in the basement. If I wanted to detect where the door is in an image and I know it's green, it's going to be like a specific shade of green or like green colors. You can actually set these filter values to represent most green colors, and everything else in your image will get filtered out. So you don't have to focus on it. You just know where that door is based, assuming your image doesn't have other green objects of the same color, you'll know where that door is in your image. That is a useful use case for that. It's used like that in many other applications in the real world. So I thought I'd just mention that. All right, so that's our third example done. We've got two more to go through, and the final example is the face tracker. I know we're about to hit our time. We'll probably go to about 8:15. Hopefully, most people are fine with that, and if you have to leave early, that's fine too. There will be a recording posted on YouTube eventually. So, any questions up to this point? Feel free to unmute or speak them out in the chat. All right, awesome. So that was example 3, filtering out different colors in your image. It's a pretty useful application of computer vision. So for our fourth example, this one's going to be pretty quick. So the last example before the face tracker is what we call edge detection. So we'll walk through the concept. There is a lot of math behind that, lots of derivatives and integrals if you've taken calculus before, lots of matrix multiplications too. We won't walk through the math. We did do a workshop on that stuff back in February with collaboration with Delta Hacks. That link should be in the presentation somewhere. We'll also post a presentation on the original event page for you to take a look at afterwards. So our fourth example will be edge detection. So we'll do that in a separate file, just as always. So right click your Python project folder, new, and Python file, and we'll name this ex_4 for example 4. All right, and this does correlate to ex_4 on the GitHub repository. If you could post that again, Young, that would be awesome. And then, as always, I won't speak this out too much. Hopefully, it's drilled into your head at this point. Import CV2 always at the top. And for this one, we'll also import NumPy. I'm not sure if we use this in this example. We'll keep it here just to be consistent with the GitHub code. All right. And for this one, we'll use a different picture file. So window.jpg is on the Google Drive. If you could post that again too, that would be great. So window.jpg is on the Google Drive. You can download it from there if you haven't done so already, and just drop it into your Python directory over here. And we'll read this file into our program. So as we used the last time, it's called cv2.imread. That is the function name, so image read, it's a short form of that. And we'll pass in window.jpg, that is the file's name. It will read that image, we'll store it in that variable over there. And for this one, we'll create 2 windows as well, show the original and the afterwards. So first one is going to be called original image. And again, we want to pass in cv2.windowNormal as a parameter. We'll create a second window using the name window function as well. We'll call this edge detection. Again, cv2.windowNormal. It's pretty standard at this point. And from that GitHub code, again, we have to create track bars. We'll not walk through that because it does take a while. It's just boilerplate code. From ex_4, I'll just paste that in the chat. This is a file that we're looking at. We'll just copy from lines number 9 all the way to line number 24. And we'll just paste that into our code over here. This again just creates track bars. You can look up how it works online. It's not that important for understanding computer vision. All right. And what we want to do is we want to create a function called edge detection. All right, and in this function, we'll do edge detection. And if you guessed, OpenCV has a function for edge detection. There's actually quite a few functions for edge detection. There's different algorithms that use different methodologies to detect edges inside images. And the one we're going to use today is called canny edge detection. So it's just a simple function call. You just pass in, you want to save the edge detection image inside the variable called edge. And to perform edge detection on an image, we use cv2.canny. That is the algorithm we're using. So canny edge detection. And you want to pass in the image, all right, img. We loaded it up here. And you want to give it a sensitivity for your edges. So we pass in canny lower and canny upper into the canny function. That basically describes I guess it's kind of like a filter too, but it also can describe sensitivity of the algorithm, as we'll show you. So this is all you need to do to perform edge detection on an image. It might seem incredible how small the code is. Most of it is just visualizing it, right? So we can show both of these images. So in the original, in the original image window, what we'll do is we'll display our img variable there, the original image, and cv2.imshow again. Inside there, we'll display the edge inside the edge detection window. We'll display the image that has the edge detections, and we'll run this forever as long as our program is running and we don't exit. So for that, we'll just do a while true loop. Let's call the edge detection function in there. That should do the edge detection, and then we'll wait for we'll wait for 10 milliseconds. All right. And so any questions about this code, about any like functions or like things that we're doing here? Should have 37 people. That's awesome. So to explain the canny function, I'll have to delve into a little bit of math. We do have a Discord, and what we can do is, just for the sake of time, it is 8:04. We want to get to the face tracking example. Kylan will probably post a link to the Discord on this Zoom chat. And what you can do is you can join there. And what we can do is these questions that will probably take a while to answer. We can discuss those on the Discord afterwards if you're interested, because to explain that will probably take a while. So yeah, just look around for that Discord link at the end of the workshop. before we close off, and then we can discuss that further. Great. I'll have to walk around again for the light to turn on. This room is great. There you go. Hopefully that'll be the last time. All right. Thank you, Young, for posting the Discord link. All right. So back to the code. Sorry for the distraction there. So let's run this. And as always, right click the tab, run ex_4. All right. So this has created two windows. Just want to separate them if they're on top of each other. So on the right here, we have the original image. On the left, we have the image with the edge detections, right? So we'll just make them slightly bigger. All right, so the sensitivity of this algorithm is really high with the values that we have. So 0 and 0, literally everything that it can detect as an edge is being detected as an edge. And that's because images have noise. So if you ever taken a picture at night, you'll see there's like artifacts, there's like graininess, like random color fluctuations in your image that make it look not so good. They exist in every image. It's just our circuits aren't perfect. They can't capture everything perfectly. So there's noise in images. That can be the cause of all of these random edges that you see. So everything here is an edge that it detected. And what we can do is we can actually decrease the sensitivity of this algorithm by moving around these sliders. All right. So if you move these sliders around, you'll see that all of the edges that aren't really edges will start to go away. And if you decrease the sensitivity too much by moving them even further up, what will happen is that even things that are edges won't be detected as edges. So let's move them down to reasonable values. So around there. So as you can see, you can identify edges in the original image and also on the left. You see there are edges in the window frame, there's edges on the road, edges on the houses. So that is just wanted to do this pretty quickly. I think it's a pretty cool application inside function inside OpenCV to just literally pass in an image and get edges out on the other end. So that's pretty cool. Hopefully you guys think so as well. All right, so that was just a quick example on the edge detection. So the advertising for this workshop mentioned the face tracker. So let's do that now. That's our final example. Also, thank you for everybody who has stuck around this far. We'll create another Python file as you have before and call this ex_5, so example 5. So this will be example 5 on the GitHub. Just post a link to that file. This is example 5. All right. You might be, if you haven't used OpenCV before, you might be impressed by how short that code is. You think that a face detector would have like lots of code, and it does. It's just that because we're using OpenCV, we don't really have to be concerned with like the low-level implementation of it. That's what's great about OpenCV. It lets us do many things without having to write everything ourselves. All right, so again, as always, import CV2. Done this many times by now, right? Also, forgot to ask any questions about example 4, the edge detection. Any questions about that one? Again, Aryan, as I mentioned before, if you join the Discord link, the Discord, and we can talk there afterwards about the caddy function and what it does. Answer your question. It seems like we don't have questions for the edge detection example. So let's move on to the face detection algorithm. So for this one, we'll be using two files that are also on the Google Drive link. Yeah, the recording will be posted on YouTube shortly after the workshop. Young, if you could post the Google Drive link again, that would be awesome. Just for the last time here. So we'll need this XML file. So it's called Har Cascade Frontal Face Default. There are many XML files like this. It's called a classifier. We'll talk about that. All right, so what we're going to use today is called a Har Cascade. This is the Viola Jones face detection technique. Fancy names for everything. I guess those are the people that came up with it. So this is a binary classification problem. It goes through your image. It looks at like different things inside an area of an image. and it will either output 1 or 0, depending on if the feature that you want, in our case, a face, is there in that box or not. Similar to the blurring algorithm with like checks, blurs, looks at it, blurs. This one kind of looks at a specific section of an image. Is there face there? If so, great. If not, then moves on. Face, face or no face, and it will just scan through your entire image line by line. And these are trained on thousands of faces, and you'll see that they're not the most accurate algorithm. They are pretty ancient, but they're pretty fast, and you can still use them today. So this is an animation of kind of like how it works. As you mentioned before, scans through the image, right? And once it finds the feature, the face, it will tell you, it will output that box, and will actually display those boxes as well. All right, so to get back to our code here, you should have the XML file and vid2. I should have that as well. All right. Oops. I'll just go to the Google Drive. I think I might have forgotten to download it. I'll just right click. And download it. I'll just give it this directory and just download it in here. All right, that should be good. If you haven't downloaded, you should do it too. All right, so as we've done in previous examples, we'll use this video file by using cv2.video capture, and we'll pass in the name of that video. So vid2.mp4. We'll place in a variable called capture this time instead of cap. That's fine. And we'll use a window to display our outputs, so the faces. And we'll name this window video. And again, we want to pass in cv2.window normal. And what we want to do is we want to actually load in that XML file here, the har cascade. This file basically defines features. It will tell the classifier what defines a face and how to detect it essentially. So we'll call this face cascade because there's a har cascade classifier. And we'll call this cv2. We'll use the function called cv2. Cascade classifier, and then we'll give it the file name here. So it's har cascade underscore frontal face default.xml. There are many of these classifiers. There's classifiers that will detect cars. There's classifiers that will detect eyes. There's classifiers that will detect animals, for example. You can download a classifier for that and use it for anything essentially. And we want this to loop forever as long as we have something in our video file to read, and then we'll read it. All right, so ret frame, we've done this before, cv2.read. Oh, sorry, that should be capture.read, because that's how we loaded the video up here. And if not, ret, so if there's nothing left to read, we'll break out of our loop. All right. And then for the Viola-Jones face detection technique, it does require you to use a grayscale image, or what people usually refer to as black and white. So we want to convert the color spaces again from RGB to grayscale. So we'll do that using the CVT color function as we did earlier. We'll pass in frame, and then we want to give it what we want to do for the color space conversion. So we'll do CV2 color RGB to gray. So this will convert your image to grayscale, and we'll just show what that looks like in just a second. So to do that, we'll just do cv2.img show that function again. In video, we want to show gray. And again, just to run the file, ex_5, just run it from the tab. All right, this won't do anything because we forgot the cv2.wait key function. That's always needed to display something inside a window. We'll pass in 0 for now, so it will wait for us to press a key on our keyboard. There we go. So you do have to press place once. The first frame is just black. It's empty. So you might be familiar with this video. It's a great video. Uh, so this is the grayscale video. I'm sure most of you have seen what the original looks like. This is just a black and white version of that. It looks like it's from the 1930s. You may. All right. So they want to detect Rick Astley's face. All right. So the way we do that, we'll actually get rid of this because we don't want to look at the grayscale version. So faces, we'll actually extract the faces by running the image through the classifier. So I'll just do this quickly because we're pretty much out of time. Face cascade dot detect multiscale. So this code is on the GitHub. You can maybe just copy paste it from there. So image, we pass in the image. We pass in the size of the box, as I mentioned previously. You want to be able to define the size of this box that will loop through your entire image. All right. So for us, we'll start off by using 30 by 30. That's a pretty small box. For flags, we want to pass in cv2.cascade scale image. I believe all that does is that it scales it so that the box can cover every part of the image, and it also makes it faster, I suppose. I'm not too sure about what that flag does, but I think that's what it does. So we'll just put in a for loop here. So x, y, w, h in faces. So this will loop through. So this faces variable here is just a list of faces, like rectangles that it detected. So you can just loop through their x, y coordinates, their width and their height. And we'll copy line number 20 from the GitHub, the example from ex_5.py. So that's OpenCV code to draw a rectangle onto an image. OpenCV has lots of functionality for drawing things. And then what we'll do is we'll do cv2.imshow video, and then we'll display our frame. So this will draw all three detected rectangles onto our frame. And then we want to do cv2.waitKey 10. So we'll wait 10 milliseconds before continuing. And we'll close the previously running program. And then we'll try to run this. And then you might see what we mean by inaccurate. So as you can see, when it does have a face, right, it is detecting the face, but it's also detecting other things that aren't faces, which is why we said it's not very accurate. And the way you can make this more accurate is by playing around with these parameters over here. So chances are your minimum size box isn't a 30 by 30 box. Your face is probably going to be bigger than that in an image, at least in this one. So what we can do is we can actually make the minimum size smaller. So it will filter out all of the small boxes that you saw there. It won't even consider those. We'll use 180 by 180 as a box, and you'll see that all of them won't go away, but most of the other boxes that were there previously will go away. There are still quite a few boxes. So you might notice that when Rick Astley there turns his face around, it stops detecting it. And that's one of the problems with this type of algorithm is that it is very specific because it's only trained on frontal faces. It will only detect when your face is looking straight on. That's why it's called a hard cascade frontal face. And you can find algorithms that are more, I guess, hard cascades that are more prone, like more flexible with the orientation of the face, but the one that we're using here is very specific. So any questions about this? If you would like, you can come to our Discord and then we can discuss more about how this algorithm works behind the scenes if you wish. So that was most of the content for the workshop, the coding part. One last thing, I can't do this right now because my webcam is being used by the Zoom at the moment. What you can do here to access your webcam, you can just, if you're on a laptop or a computer, you can just pass in 0 over here. If I do that, it will mess around with my Zoom because two programs, I'm not sure if they're allowed to use the same webcam at once. But if you replace the video file with just 0 there and run the code, you'll actually be able to see yourself. And then hopefully, if the algorithm is fine, maybe you can play around with the min size over here. You should be able to track your face. I can't do that because the webcam is being used by Zoom, but you can try that. Okay. I am not sure if that will work either. Because when I did try that before, the webcam is like a resource that has to be acquired. I'm not sure if it will let us do that, but you can try it out. And let me know if it works. So let's replace the video file name with 0 over here and run the code. If you have a webcam, it will use that. Yeah, so that's like all the coding stuff for the workshop. Just some closing stuff. We do have some resources on this website, on this PowerPoint that we'll upload to the events page where you can see them later. And this is a funny code. Maybe once you are an expert in computer vision and you maybe just started off over here and you go through all of the math, you know everything. This code will make sense later. It's a guy named Jim Blaine. Is pretty influential in the computer vision space. All problems in computer graphics can be solved with the matrix inversion. It is funny if you have taken linear algebra and you just study how these matrix operations work inside computer graphics. If you haven't taken linear algebra, you will eventually in comp sci engineering, even for BTech. All right, so yeah, and that's a great application of that. So that is all for the workshop. Do you guys have any questions regarding this? Feel free to unmute or type them out in the chat. And let us know if you put in 0 here and it worked for you. If I was able to track your face. All right, seems like we don't have any questions. So I will upload the recording to YouTube and it will be on the events page, like the where you RSVP for this event. Once you go there, it will show up eventually. YouTube does take some time to process it and things like that. It will be there. So yeah. Before you leave, we do have some more closing remarks from GDSC. Thank you for coming out to this workshop. Thank you for staying all the way till the end. I know we went quite a bit over time. It usually happens. You will be able to see, I believe it is a feedback form for the event. It will be sent to your email, I think, right, Kylan? And then never mind the Teams thing. You'll be able to fill that out, and I would love it if you guys would fill that out so we can make our future events better and just help us make GDC an even more welcoming and productive place for everyone. And hopefully you learned something today, you enjoyed the workshop. And yeah, we will also update the event description with the GitHub and the Google Drive. So yeah, everything is done. Thank you for coming out. Thank you for staying. So what makes this club a Google Club? Because it sounds like you guys are directly connected with Google. We are connected with Google, but it's not like we're like, I guess it's not like if you work for us, you work for Google. It's not like that. We're just a student-run club that is supported by Google, and we're able to use that affiliation there. So yeah, that's everything. How can we get the t-shirt of the Google Club? I am not sure if we have t-shirts yet. So do you have free Google Card credits or something? I believe we do have something like that. Not sure too much. If you join the Discord, Young, if you could post that link again, maybe you can ask that question there and the admins will be able to tell you that. Yeah, so we do have a Discord that you can join and you can continue our conversations over there. This event will be closing around 8:25. So why is the Discord inactive? Is it usually like this? So most of the planning happens so the Discord has a lot of hidden